Yes, thank you, Sarah. Pleasure to be here. I'm an environmental and energy economist. I work on electricity markets, carbon markets, lots of transportation policy, and then deforestation and biodiversity. And I also teach courses here in energy markets and policy and climate and financial markets. So I want to talk to you today about electricity, because electricity is kind of the path to a green future, right? The plan is typically something like, let's electrify everything and then clean up the power grid as fast as we can. And that is a good idea, but there is some barrier. The way in which we price electricity is sometimes a bit counterproductive. So most residential and commercial customers actually pay a flat price for electricity, even though the actual cost of generation varies dramatically from hour to hour. Now, there is a pretty good textbook solution to this. It's called real-time pricing, where the price you pay would be fluctuating along with the cost of generation. And why is that efficient? Well, it would give you really good incentives, for example, in the summer, to put your thermostat a couple degrees higher when prices are high during a summer peak. It would also incentivize you to charge your car, your battery, or do your laundry during low price hours, say, in the middle of the day or at night. And that would allow more renewable energy to enter the grid. And moreover, the other benefit is that we make those extreme peaks a little less pronounced, so we don't have to build as many dirty peaker plants just to serve the grid, to keep it running for a couple hours a year. So there's lots of benefits to this. But then there's issues, and the big issue is it can be kind of scary to be in a real-time pricing plan. A couple of years ago in Texas, prices soared, and some consumers that had signed up for these plans were stuck with a $10,000 or more monthly electricity bill. So you can kind of imagine, for that reason, these pricing plans are not very popular. The question is, are there other kinds of pricing that can come to the rescue here? So the first option would be what's called time of use pricing. So basically, these are different electricity rates for different, let's say, times of the day or days of the week or seasons. You're probably familiar with the easiest one, which is just peak versus off-peak pricing. Here you see an example from Pennsylvania. So the black dots are, you can sort of consider that these are wholesale prices, roughly speaking, the production cost of electricity for a given hour in a given location. The blue and the red lines are showing you a peak off-peak pricing plan, but you can see it's doing something to capture those peaks, but it's still pretty far off. So during the peaks, the price you pay is still way too low, and it still gives incentives to over-consume electricity. So a lot of people have already established in research that this simple peak off-peak pricing, it really misses what you're trying to capture. And what's worse, you need to set these prices in advance, so you might even get the average price wrong. So what utilities have been trying to do is to make these systems more and more sophisticated. So instead of peak off-peak, it's going to be a different price depending on the day of the week, the time of the day, even the season. And what I and co-authors have tried to do is try to see, does that really help to give efficient pricing signals? So we use data from all 7 major wholesale markets in the US, hourly pricing data, for the last decade. And what we're calculating, what I'm showing you here, is sort of what's the percent of the gain that you could get from real-time pricing that these time of use policies achieve. So you're looking at 4 different policies, from simple peak off-peak all the way to much more sophisticated. The different colors are the different markets in the US, different regions. And on average, the gain is kind of limited. It's about 10%, right? So this is not a magical solution. And what's worse, actually, if you make it more and more sophisticated, it seems to hurt more than it helps. So that current trend towards more sophistication is actually not helping very much at all. So what's the other option? The other option is critical peak pricing. It's something like you get a notification on your phone that, hey, tomorrow it's going to be really expensive to use electricity between 4 and 7 p.m. Be prepared. That is certainly helpful, that as you add more and more and more of those days, your utility can call more of those events. It's going to capture a higher percentage of the efficiency gains that real-time pricing could get you. But even with 20 of those days in the year, again, on average, you only capture about 10% of the gains from an efficient real-time pricing system. So the two systems together, the two systems that utilities actually use, can get you at most a fifth of the possible gains. So what else can we do? So here's what I would suggest, right? What you could try to do is take the sharpest edges off of real-time pricing. So in my Texas example, actually the wholesale price had skyrocketed to $9,000 per megawatt hour when a typical price is 40. What if we put consumers on real-time pricing, but we just cap it at, say, 75 or 100, which is nothing unusual. So this is not extreme. So as a consumer, you're protected from crazy prices when they would otherwise happen, but otherwise in most hours, you pay the right price for electricity. And we find that under those systems, capping it at 75, for example, gives you the vast majority of the benefits that full real-time pricing could get. So that's our proposal in this research. We think it's a very nice balance between protecting you from crazy prices, but still giving you the incentive to tweak your thermostat and charge your cars at the right times, and that'll also help increase renewable electricity penetration in the grid. So thank you for your attention, and I'll hand it over to the next speaker.